Hello students, I am Srinivasan, physics lecturer from Spark Academy. I am going to teach today certain chapters of intermediate first year 11th class. Very short questions. Very short questions. Earlier we discussed some chapters. We are discussing chapter 6 onwards now. Work, energy, power. Some questions we are discussing. Please see to it. What the first question is? Define work, power and energy. State their SI units. So just a second. State work power energy. What is the definition of work? You know, work definition is work is said to be done. First definition work is said to be done. Work is said to be done if applied force. If applied force produces a displacement, produces a produces a displacement. So work done is given by the formula dot product F bar dot S bar. F is called force, S is called displacement, Fs cos theta dot product. SI unit is what? We'll write SI unit. SI unit of work, SI unit of work is joule. SI unit of work is joule. That is definition of work. Work is said to be done if the applied force produces a displacement. Work is said to be done only when it produces a displacement. F is called force, S is called displacement, dot product. W is called work, Fs cos theta. SI unit of work is joule. So power, what is power? Power is rate of work done. Power is nothing but rate of work done or work done per unit time. The rate of work done. So power is given by the letter P. P is given by the formula work by time. So SI unit of power is watt. SI unit of power is watt. W-A-T-T, watt. Or short form you can give W. One more definition I am writing here, energy. Energy small definition I am writing here. Energy is capacity to do work is called capacity to do work. Any machine, drilling machine, anything is there, capacity is there. So capacity to do work is called energy. Capacity to do work is called energy. So work and energy are on the same. SI unit of energy is also joule only. SI unit of energy is also joule. Energy is joule only. J means joule. This is first question. Okay, second question. State the relationship between kinetic energy and momentum. State the relationship between kinetic energy and momentum. Relation between kinetic energy and momentum. Answer. You know kinetic energy is given by the formula kinetic energy. Kinetic energy EKE is given by the formula half mv square. M is mass, v means velocity. You want to write momentum. What is the formula for momentum? Mass into velocity. So I can write this formula as half m v into v. V into v. This is momentum, but velocity is not constant, variable. I want to keep my formula in terms of mass because for a given body mass remains constant. Then what I am doing is v into v I wrote, but I will write again v square. I multiply by mass and divide by mass. M v square. If I do this step is not necessary. Half mv square. Next step is this one. Don't write this step. To write this half, how to write means half PV you'll write, but that is not proper relation. Momentum is P mv v. Half mv square I am multiplying by m and dividing by m. Don't cancel m into m square half m square v square by m. Last square v square by m. So this can be written as half mv whole square by m. What is mv? mv is nothing but momentum. mv is nothing but momentum. Momentum is given by the relation. This is called what? mv is called what? Momentum. mv is called momentum. Momentum. So mv whole square by m. So half to mv means p. P square by 2. So if you don't remember this derivation, directly also you can write kinetic energy of mv square, then you can write p square by 2. In the examination, kinetic energy ke of mv square is a very short question. P square by 2m, where p is momentum, m is mass. Later, what is lateral stands for? M stands for momentum, m stands for mass. In examination, public examination, you have to write what letters you are writing, what stands for it is. Even though they are standard letter, so because P is also called power, earlier we wrote P is power. Now we are writing P is momentum. M is mass. So which physical quantity remains constant in collision? Elastic collision. Which physical quantity remains constant in elastic collision? Answer. There are two physical quantities. Both total momentum remains constant. Total momentum in elastic collision. Total momentum remains constant. Total momentum remains constant. Total kinetic energy remains constant. Total kinetic energy remains constant. Both elastic collision, total momentum before collision is equal to total momentum after collision. Similarly, total kinetic energy before collision is equal to total kinetic energy after collision. Total kinetic energy remaining constant. Okay, students. So which physical quantity remains constant in elastic collision means total momentum remains constant, total kinetic energy also remains constant. This is. State the conditions under which force does not work. Does no work, not work, does no work. Under what conditions force does no work? Answer. No work. No work means work done is zero. Work done is zero. This is a very important question. Work done is zero. Work done is zero happens mathematically if you think. What is the work done? Dot product Fs cos theta. Even though force you are applying, displacement is there. If F and S are perpendicular, if F is perpendicular, this is perpendicular symbol everybody knows, I think. Then theta is 90 degrees. Then what will happen? Work done by the force Fs cos 90. Cos 90 is 0, right? Cos 90 is 0. F into S into 0, that nothing but equal to 0. This is one thing. Second example is, even though you apply force, displacement is 0. For example, I am applying force on the wall. I am applying force on the wall, but wall will not displace. Then work done will be 0. If the displacement is 0, displacement is 0, definitely work done will be 0. When displacement is 0, work done will be 0. When theta is 90 degrees also, work done will be 0. There are 2 points. One is 1 mark, another is another mark. So problems means dot product problem you can select. For example, any dot product is there, how to do dot product. So he's telling that you just do dot product problems, scalar work done problems F into S. Such problems you have to practice. So which physical quantity remains constant in an inelastic collision? So perfect inelastic or inelastic, solution is only total momentum remains constant. Only total momentum remains constant. Only total momentum remains any collision, total momentum definitely remains constant. But in this collision, total kinetic energy is not constant. Only total momentum remains constant. Bodies undergo change in their shape. Before and after collision, if you observe, bodies undergo change in their shape in this collision. But in elastic collision, there is no change in the shape. Before collision, whatever shape is there, after collision also same shape will be there. But perfect inelastic collision or inelastic collision, bodies undergo change in shape after collision. After collision. These 2 points. Main point is this one. Only total momentum remains constant. So I think you understood. Next question. Next chapter. System of particles and rotational motion. System of particles and rotational motion. But we are discussing every chapter very short questions. I will be discussing with director. I will tell you. But here, I of course it is better to learn on very short questions from all chapters. But here, intermediate board examination. Last class we discussed in all the chapters very short questions are there. What is that? Physical world, units and dimensions, motion in a plane, laws of motion. We discuss very short question. Motion in a straight line, also very short question. Very short question is not come. There is a blueprint is there. But anyhow, it is better to become strong in all chapters. What is the objective point of question? That is very short questions. System of particles, we have two short questions will come in the board examination. Along with that, in this class, we are discussing very short question. In future, same chapters will discuss short questions and some chapters long questions also. Right, solution. Is it necessary that mass should be present at center of mass? Answer is no. There is no necessity. There is no necessity to have mass at center of mass. To have mass at center of mass. No, there is no necessity to have mass at center of mass. So what is the example? Hollow ring. Ring tenicoid, you know. Hollow ring or ring. Ring means you know how it will be there. This is ring. Ring center of mass will be outside, not on this ring, not on surface of ring. It will be a center. This is center of mass. So hollow ring, or you can take L-shaped rod. Two rods are there. You can take this example also, L-shaped rod also. L-shaped rod, if you take L-shaped rod. What is L-shaped rod? This is one, this is another. Center of mass will lie not on this, but center of mass will lie outside. But mainly, standardly they are writing hollow ring only. So there is no necessity to have mass at center. It is a point actually, where entire mass of the body is supposed to be concentrated, center of mass. Why are spokes provided for bicycle vehicle? Why are spokes provided for bicycle vehicle? To increase moment of inertia. So what is the answer is? Answer is, you know, moment of inertia means mr square. Why spokes? You know, wheels for correct rotation. Spokes are provided. You know, spokes for cycle and our bikes, bicycle wheel and even cycle also. Spokes are provided. Spokes are provided for bicycle wheel. Bicycle wheel. Sorry, cycle only. Bicycle means cycle only. Sorry. Even scooters also, of course that will be different, of course. But you can take bicycle wheel only. Provide for bicycle wheel to increase moment of inertia. 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 Just a minute. To increase moment of inertia, greater moment of inertia, greater opposition to the rotational motion. So increase moment of greater moment of inertia is given by letter, not letter, moment of short form mi, moment of inertia mi. If mi is more, moment of inertia is more opposition is created for rotational motion. More opposition is created. More opposition is created. More opposition is created. So therefore it goes created so that it goes in so it goes To increase moment of inertia, more opposition is created. Inertia means what? Tendency to remain rest or uniform motion. That is what will happen. It runs smoother. So it runs smoother. It runs smoother. It runs smoothly. Spokes are there. Smoother. Otherwise, if spokes are not there, what will happen? Cycle will get jerks. That is correctly it won't go. Spokes are not correctly, it won't go. There will be jerks while running. It will be unsafe. That's why spokes are provided for bicycle. Again, I'm telling spokes are provided for bicycle to increase moment of inertia. Moment of inertia means mr square. Moment of inertia means mr square. Mass into square of distance. Moment of inertia is more. Inertia is more opposition is created. So it runs smoothly. It runs smoother. Otherwise, jerks will come. Spokes are not there. This is this question. We cannot open or close door by applying a force at hinges. Door. In your house, you see door. This is the hinge. Is fixed here. Is fixed here door. This is the door. This is the door. You can apply force anywhere. This is called hinge. So if you apply hinge, force hinge. If force is applied at hinge, there is no perpendicular distance, right? So you measure. This hinge is called axis of rotation. If force is applied at hinge, level arm or perpendicular distance, perpendicular distance is 0. Perpendicular distance is 0. Perpendicular distance. If you apply force at hinge, you can apply force anywhere. If you apply here or here or here, torque will be there. So we can't open level arm perpendicular. So we cannot open or close the door because torque is 0. Perpendicular distance is not because torque is 0. I am writing all points to you, but you can write this force is applied at hinges, level arm or perpendicular distance is 0. That's why you can't apply force at hinge. This is called hinge or axis of rotation. This is called my axis of rotation. So I think you understood. Next question. Why should a helicopter necessarily have 2 propellers? Why should a helicopter necessarily have 2 propellers? 2 propellers will be there. This is depends on angular momentum. Angular momentum means moment of momentum is called, chemistry will learn what is angular momentum. L, nothing but mvr, mass into velocity into radius. That is called angular momentum. Why I am telling angular momentum means I am writing reason. If there were only one propeller, one propeller is there, then according to law of conservation of momentum, then according to law of conservation of angular momentum, law of conservation of angular momentum, law of conservation of angular momentum, the helicopter would rotate itself. The helicopter would rotate itself. One propeller is there. For balancing, another propeller is there. It would rotate itself in opposite direction. So helicopter is necessarily, there are only one propeller according to law of conservation of angular momentum. Law of conservation of angular momentum, helicopter would rotate itself in opposite direction. So helicopter necessarily have. So any helicopter necessarily has. So that is the question. So necessarily to compensate this, so helicopter necessarily will have necessarily, so it will necessarily have two propellers. Okay, student, this is the answer. So now the every chapter is saying practice some problems. So short answer question, my time is there, we will do it. Important problems also. Now we are doing another chapter called oscillations. Chapter 8 is called oscillations, means simple harmonic motion. Two examples of periodic motion which are not oscillatory. Two examples of periodic motion which are not oscillatory. Periodic motion means, what is periodic motion? First answer. Periodic motion means time period remains constant. Time period means time taken to complete one rotation or one oscillation. Periodic motion means time period remains constant. That is called periodic motion. So which are not oscillatory means rotatory. So example for this, planets are revolving revolving around the sun in elliptical orbit. This is not to and fro motion, this is rotatory motion. This is rotatory motion. But time period is constant because 1 year. Earth takes 1 year to complete one rotation. Time period remains constant. Second example, geostation satellite you can take. Geostation satellite which revolves about the Earth. Satellite which revolves about Earth. Satellites revolving about satellite. That is geostation satellite I am taking. Geostationary gravitational get geostationary satellite. Here time period is how much? 24 hours. Satellite revolving about planet. Revolving about this is not oscillatory motion. Revolving about Earth. Revolving about Earth. Okay, so this is called not oscillatory. Oscillatory means to and fro motion. This is not to and fro motion at all. This is not to and fro motion at all. Even revolution of electrons around the nucleus also you can write. I wrote physics examples only. If you want chemistry example, revolution of electrons in the orbit. So it's not oscillatory told now. They are not. This is the example. Can simple pendulum be used in artificial satellite? No. Answer is no. Answer no, because what is artificial satellite? Satellite is a freely falling body. Satellite is a freely falling body. Freely falling means net acceleration is how much? G minus G is equal to 0. This is called net acceleration of. What is time period of simple pendulum? 2 pi square root L by net acceleration of L by E. Net acceleration. This is called net acceleration. A net 2 pi square root L by 0. Means time period is what? Something by 0 is time period is infinite. Infinite means it is not oscillating. It is taking to complete one oscillation infinite time, very lot of time. So therefore pendulum ఇది చాలా ఎక్కువ టైం తీసుకుంటుంది. Time period is infinity means to complete one oscillation it is taking more time. That means what? అంటే అర్థం ఏంటి? Pendulum doesn't oscillate. Pendulum doesn't oscillate. So pendulum oscillate కావాలి. That's why you can't use this one. Okay, so this is called simple pendulum question. Now we are doing gravitation chapter. Chapter 9, gravitation. Answer. gravitation constant G. What is the formula for this? F force or distance square by m1m, because F is given by the formula G m1 m2 by r square. G is gravitation constant, m is mass, r is distance. Okay, students, how to create dimension formula? First, units you can write. SI unit I am writing. Force means Newton, distance means meter square, r means distance. Distance means meter and meter square. This is kg square. So SI unit is Newton meter square into kg to the power of -2. Newton into meter square. This is SI unit. Dimensional formula. Dimensional formula should be in terms of MLT. Dimensional formula. So how to write dimensional formula for force? Dimensional formula force ki manam mass into acceleration. Then derivation force గుర్తుపెట్టుకోవాలి. You have to remember na force dimensional formula mnt minus 2 into distance r L square, r means length, kg square, kg means mass, m square. I'm writing once again explaining. Force dimensional formula we have to remember. Force dimensional formula, df means dimensional formula of f mlt minus 2. If you remember force, so many quantities you can derive, because work, force and displacement. Okay, like that. So many things you can do. Pressure force by area L square, like that. Force you have to remember. So here m power is how much? Nothing is there, means power 1. 2. 1 minus 2 minus 1. So dimensional formula ultimately what will happen? M minus 1 L into L square L cube 3 to the power of minus 2. This is dimensional formula of gravitational constant. It is very important for units and dimensions also. Question M minus 1. Generally M power either will be 0 or 1. But here special negative dimensions of mass we are going to get. This is a physical constant. Anywhere it remains same. G will remain same. Hydrogen is abundant around the sun, but not around the earth. Explain. So here hydrogen abundantly available around the sun. Why it is abundantly available around sun? Because RMS velocity, RMS velocity of hydrogen, something is there, some data is there. Answer is RMS means root mean square. Velocity of hydrogen molecules. Hydrogen, how much? I am giving some data. RMS velocity of hydrogen. RMS velocity of hydrogen. RMS velocity of hydrogen. Velocity of hydrogen. Hydrogen is approximately, is telling 2 km per second. What is the escape velocity with respect to Earth? We are seeing. What is escape velocity? To escape for this, escape velocity on Earth, it easily escapes, because escape velocity with respect to this 11.2 RMS velocity. So this 2 kilometers per second, but sun, escape velocity of sun is how much with respect to Earth? Escape velocity, sorry, not half. Escape velocity in Earth on sun, how much? Sun is very massive, 620 km per second. 620 km per second. Escape velocity surface of sun is 620. Escape velocity surface of Earth is 11 point. Escape velocity of sun is greater than escape velocity of Earth and RMS velocity. So escape velocity, V escape velocity on sun is very greater than escape velocity with respect to Earth, as well as greater than RMS velocity. of hydrogen. Therefore, hydrogen is abundantly, because it is difficult to escape from sun, hydrogen is abundantly than earth, compared to earth, abundantly available on sun. Why? This is very, very larger. Escape velocity of sun is very, very, to escape very difficult. That is available when compared to earth. So escape velocity of sun is greater than escape velocity of earth, then RMS velocity. RMS means root mean square velocity is 11.26 km. It is difficult to escape from the sun. That's why hydrogen is abundantly available on sun than on earth. Okay, student. What are polar satellite? You know geostationary satellite? I'll tell you about geostationary satellite. It revolves about the earth from west to east direction. Geostationary satellite revolves around the earth from west to east. Time period is how much? 24 hours. Polar satellites are different. They revolve from, they are from low altitude. They revolve from first point. They revolve, they revolve, they revolve from north to south. They revolve from north to south. Geostationary satellite west to east, north to south. Height is, it revolves at the poles. It revolves at poles, because north to south direction is revolving. So poles are nearer to north and south. Geography north, geography south, it revolves at poles. Geography north. Time period of polar satellite. What is time period of polar satellite? Nothing but 100 minutes. 100 minutes. But mainly you write this point is important. Polar satellites. The height is, it is at low altitude. The satellite is at low altitude. Satellite height is low. Height is low. That is about 500 kilometers. 500 kilometers to 800 kilometers. 500 kilometers to 8. This is data low. If you write low height, it is enough actually. Polar, if you remember, you can. But main point is north to south. So that is called polar satellite. So that is regarding gravitation. That is regarding gravitation. So now we tell about Hooke's law, mechanical properties of solids, chapter 10, mechanical properties of solids. What is mechanical properties of solids? State Hooke's law. No, mechanical property elasticity. This is also called elasticity. Elasticity. Okay, students. State Hooke's law of elasticity. Within elastic limit, stress is proportional to strain. Stress is proportional to strain. Within elastic limit, stress is, what is stress? Force, restoring force by area. What is strain? Linear strain means change in length by original length. Volume strain means change in volume by original volume. Within elastic limit, stress is proportional to strain. Stress by strain is a constant at a given temperature. Stress by strain is called modulus of elasticity. Modulus of elasticity. This is constant. This ratio is constant. Let us say modulus of velocity, you say some name, you give E, like that, some modulus of velocity. E is constant. E is constant for a given material. For a given, see, if you write this is enough actually, then this is proportional to strain. Stress by strain is modulus. If you write that, enough. E is constant for a given material and at a given temperature. And at a given temperature. Right. State two examples of perfectly elastic and perfectly plastic bodies. Answer. First I am giving perfectly elastic. Perfectly elastic bodies I am giving. One is quartz material is there. Perfectly elastic means strain should be zero. Strain should be 0. Perfectly elastic bodies. Perfectly elastic bodies. Perfectly elastic bodies. Quartz. Quartz material, perfect elastic material. Perfectly plastic. Perfectly plastic. Perfectly plastic. In rigid body also you can quartz fiber, rigid body, can write perfectly elastic. Then Duff. Duff means atta powder. So powder you mix with water to make chapatis. You extend it, it won't come back. So this is perfect plastic bodies. Data. I wrote 2 examples. You can collect some more examples. State the units and dimensions of stress. Answer. What is stress? Stress is nothing but stress is nothing but restoring force by area. Restoring nothing but restoring force by area of cross section. Area of cross section. Stress is nothing but force by area. Restoring force is force by area. This is the formula. Now, why you are written formula? Formula is not necessary, but what is SI unit? SI unit means Newton, area means meter square. SI unit is Newton by meter square, Newton meter to the power of -2 or Pascal. You can write Pascal. Dimensions, these are dimensions. Dimension formula already told, force you have to remember. ML T minus 2, force dimension formula. Area means L square. Area means L square. L power 1. Therefore, it will become M L power -1, 1 minus 2 minus 1, T minus 2. Stress means force by area of cross section. SI unit is Newton per meter square or Pascal. Dimension formula, force dimension formula, you remember. Nothing is there means always power is 1 only, student. M power 1, L power 1, T power -2. By area L square, L into L. So 1 minus 2, you know mathematical rule. ML minus 1, T minus 2. These units and dimensions of stress here. Okay, student. So one by one, once again, we'll see and we'll do necessary 1 or 2 problems. Time is there. I'll revise once. Any difficult question is there, we'll see once again. We discussed about 12 questions. Discussed about 12 questions. Define work power energy. Work is said to be done. The applied force produces displacement. When displacement is there, mainly work is done. W is given by formula F bar dot S bar or Fs cos theta. SI unit of work is joule. Power, rate of work done. What is meant by rate of work done? Work by time. SI unit of power is watt or joule by second or watt, W. Energy is nothing but capacity to do work is called energy. SI unit of energy is joule. Relation between kinetic energy and momentum. You can derive kinetic energy half mv square, or kinetic energy is also given by Ke means kinetic energy. It is given by the formula v square by 2m, where p is nothing but momentum. P is nothing but momentum. M is nothing but what? Mass. M is nothing but mass. So in examination, always when you are writing formula, you have to mention what is M, what is V. So you are compulsory write. Compulsory you have to mention. Which physical quantity remains constant in an elastic collision? Which physical quantity remains constant in an elastic collision? Total momentum remains constant. Total momentum is conserved. Second point, total kinetic energy also remains constant. Total kinetic energy is conserved. Conserved means remains constant. State the conditions under which force does no work, not work, does no work. No work means work done is 0. So I'm taking the formula. W is equal to Fs cos theta. F is force, S is displacement. Cos theta. So F is perpendicular. This is perpendicular symbol. F is perpendicular to S. What is the angle between F and S? Theta 90. Theta is 90. Work done is 0. Fs cos 90. So it is 0. For this example, I'm telling now. So a person is walking along the road, or porter is walking along the road or railway platform, having some weight on his head. Porter, you see, railway coolie, take weight. So person not only bears his weight, even load weight also will bear. That weight will be acting vertically downward, but is walking along the platform. Displacement, that is horizontal. Person, for example, person is there. The person is there. Load is there. He is walking. He is walking along the road. Displaces like this to the point. So this is called displacement. So weight will act like this. So angle between them is 90. Example. So second I am told this is work done here. For example, I told S is 0, W is 0. So even though the some angle is there, 30 degrees, 45 degrees also, displacement is 0, work done will be 0. So failing to displace a ball, even though you apply the force, pressure you apply, force you apply, but then becomes 0 because displacement is not there. Because displacement is not there. Which physical quantity remains constant in an inelastic collision? In an inelastic collision, only total momentum remains constant. Kinetic energy will not remain constant. Kinetic energy will not remain constant. 1 minute. Kinetic energy remains constant. Bodies undergo change in shape. In inelastic collision, what will happen? Bodies undergo change in their shape. Next, is it necessary that a mass should be present at the center of mass? So I gave two examples. There is no necessity to have mass at center of mass. Mass at center of mass. Mass at, mass at center of mass. Sorry. Mass at center of mass. 1 second, right? There is no necessity to have mass at center of mass. Example is hollow ring, tenicoid, I told. Here, center of mass is not lying on the ring, it is outside. L-shaped rod also. This rod, two equal length rods is there, but not lies on the rod. Outside center of mass will lie. So the two examples I have. Standard example is this. Next, why spokes are provided? Do you know cycle basic wheel spokes? The rods, thin rods. Spokes are provided for bicycle wheel to increase the moment of inertia. Moment of inertia is more opposition is created, so it runs smoothly. It runs smoother. The spokes are not there. Zigzag, the wheel will not run smooth. Will not go. Jerks will be given. That is not. That is dangerous. So it will give jerks. So that is why spokes are provided for bicycle wheel. This is very important question. Why we cannot open or close the door by applying force at hinge? In houses doors will be there. Open a door, there will be door handle will be there. Where door handle is kept? This is door handle is kept. This is called door handle. This is called handle. This lies at some distance, right? But here is not necessary to draw this one. Actually, showing you, you close or open. Practically, you think. So if you apply the force here, door not parallel to the door, but apply perpendicularly at an angle force, definitely it will move. Close or opening the door, you can move. But force is applied at this point. So if force is applied at this point, level arm or perpendicular distance is 0 because perpendicular distance measured from this point only. This is called axis of rotation. Perpendicular distance is 0 because you are start from this point only, from the hinge only. So you are taking force at here. You cannot open or close the door because torque is 0. By applying, you try at any time applying force at the hinge. Hinge means where you are fixed. There you apply force at any angle, it won't move because torque is 0. Torque is nothing but 0. You cannot open or close the door by applying force because level arm. Why should a helicopter necessarily have two propellers? If there only one propeller, then according to law of conservation of angular momentum, the helicopter would rotate itself in opposite direction. So helicopter necessarily we have two propellers. So necessarily we have two propellers to balance this rotation and go in a horizontal direction. Helicopter, because helicopter rotates, upper it will rotate fan, body also should rotate opposite direction so that will balance so that helicopter goes in forward. So here oscillations chapter. What is periodic motion? Periodic motion means time. What is periodic? Time period should remain constant. What is time period? Time taken to complete one rotation or one oscillations. Examples. Planets are revolving around the sun in elliptical orbit. This is rotatory motion. Sorry, constant I wrote. Sorry, remove this, Nana. Students, this is rotatory motion, not rotatory constant. This is rotatory motion. Satellites are geostationary revolving around Earth. Here also time period is 24 hours. Polar satellites also you can tell. Geostationary satellite also you can tell. Or electrons revolving around the nucleus also you can tell in an orbit. Next, can a simple pendulum be used in artificial satellite? So artificial satellite is a freely falling body. Freely falling means net acceleration is 0. Time period formula is 2 pi square root L by G. 2 pi square root L by A net. So 2 pi square root L by 0. Something by 0 is infinity. Infinite. So pendulum doesn't oscillate. So time taken to complete one oscillation is very, very long. You can't count means if you leave at one end, it is not coming to other end at all. It's not moving at all. So you are not using this. Next, gravitation. State the units and dimensions of universal gravitational constant. Universal gravitational constant is given by the formula F is equal to gm1 m2 by r square. Newton's law of gravitation. From this G is Fr square by m1 m2. The SI unit F force will be Newton, distance in meter square, mass into mass. Different mass also will have same unit only. Kg, mass is kilogram, this is also kg. Kg square, Newton meter square, kg to the power of -2. Dimension formula, force dimension formula you have to remember, mlt minus 2. Or you are derived from mass into acceleration. That is difficult. mlt minus 2 into r square. So again, because why difficult means if you ma, again acceleration you should know L by t square. Changing velocity by time. It will take some time. So force dimension formula, if you remember, it is very safe. mlt minus 2, distance L square by m square. M power 1, m power square, m power minus 1, L into L square, L cube, e to the power of -2. That is dimensional formula. So hydrogen is abundant around sun but not around the earth. That I already explained. So what are polar satellites? They revolve from north to south. They revolve from north to south. Satellite around the earth, not south, around earth. Around earth. It revolves at the poles. Time period of polar satellite is 100 minutes. Satellite height is very less. 500 kilometers to 800 kilometers. Geostationary satellite means 36,000 kilometers height is there. Now, mechanical properties of solid. Velocity. State Hooke's law of velocity. Within elastic limit. Beyond elastic limit, what will happen? It will break. Some metals will break, some metals get extended. So stress is proportional to strain. That is called Hooke's law. Stress by strain is equal to modulus of elasticity. I am giving some name E, my own name. E is constant for a given material and at a given temperature. So stress, this is a very important point you are right. This is important point you are right. Then due to examples, perfect elastic and perfect plastic body. Perfect elastic is quartz, silica, made of silica dioxide, quartz. Plastic body duff. I think duff is nothing but chapati powder, mixing in water. Duff. So next question. Name the units and dimensions of stress. Stress means what? Restoring force by area of cross section. Stress means force by area. Yes, force by area. SI unit is force newtons area meter square. Or Pascal, special name is there. Pascal PA. Dimension formula, force dimension formula ml t minus 2. M power 1, L power 1, t minus 2 by area L square. So you get M as it is 1 only. 1 minus 2 minus 1, ml minus 1, t minus 2. Not only stress, even for pressure also, dimension formula is same only. So this is the discussion of the problem, students. Okay, wow. 1 second, students. So I just do one problem. Time is there for us. I'll do there. Some space is there. I'll show you. Here, See students, I'm doing some problems. Okay, maybe very short question or some problems. I'll do on scalar product and vector product. One problem I'll do that will be useful to you. That will be useful to you. In system of particles, one important problem is there. Example problems they told. So I'm doing one problem. Then problem. Find the example problem side. 1 second, friends. Example problems from textbook we will do. Just a minute, student. Don't leave how much time is over. Automatically it will be cut. But I'm telling you, an important example problem is there under vector product and scalar product. Find the scalar and vector product. Find the. I'm writing one problem. I'm writing a bar is nothing but given by the equation 3i minus 4j plus 5k. K means z direction unit vector, j means y axis unit vector, I cap means x axis unit vector. B bar, one more vector is given, minus 2i plus j minus 3k minus scalar product. I'm doing scalar product. What is scalar product? Is nothing but a bar dot b bar. A bar dot b bar, how will you do? 3i cap minus 2i cap. I dot I is 1. 3 into my only numbers you multiply. I to I, j to j, k to k. 3 into minus 2, minus 6 plus 4 into 1. J quotient is 1. So nothing but 4. 5 into minus 3, minus 15. So minus 6 plus 4, minus 2, minus 15. 1 second. 3i minus 4j plus 5k minus 2i plus j minus 3k. 3i minus 4j plus 5k, correct? Minus 2j plus 3k minus j. 5 into minus 3, 15. This is minus 4. Minus 4 into 1, this is minus 4. I'll write once again. Minus 6, minus 4, minus 15. So minus 25. Minus 25. Here, minus 4 into plus 1, minus 4. So this is 5 plus 5 into minus 3, minus 15. Dot product is very easy. I to I bar, I dot I is 1, j dot j is 1, k dot k is 1. That's why you have to multiply. You need not multiply remaining 1 because I bar dot j bar is 0, I bar dot k bar is 0. That's why you can only I to I, j to j, k to k. That's how scalar product can be done. How do we vector product? Same vector product how to do. A bar cross B bar how to do. I'm telling A bar cross B bar. Determinant you have to take I, j, k elements 3, minus 4, 5. A bar cross B bar. First you have to write this one. Then next minus 2, 1, minus 3. The determinant, you know mathematics, determinant. How to do determinant? I'm telling you determinant how to do. I'm telling you determinant how to do. I, first row, first column. First row, first column is close. Then you will have minus 4, 5 and minus 3. This way you have to multiply first. Minus 4 into minus 3, 12, minus 5. So, and fast I will tell you, minus j, second one minus j it will start. First row, second column if you multiply, 3 into minus 3, minus 9, 5 into minus 2, minus of minus, plus 10 it will become. Plus k cap into first row, last column. 3 into 1, 3 into 1, 3. So, minus 8, minus 8. Minus into minus plus, minus and originally is there, minus 8. To do it, you are going to get the answer. You are going to get the answer How will you get the answer? The answer I'm telling 7i minus j minus 5k. 7i minus j minus 5k. This is the answer for cross product. So this is a very important problem which is coming for short question, actually short question problem. So only one asked means dot for 2 marks. Cross product is asked also 2 marks. Together they will ask 2 plus 2. They are going to do 4. Dot product is easier to do, but cross product is determined your mathematical method. Mathematical కొంచెం చూసుకోవాలి. క్రాస్ ప్రోడక్ట్ ఎట్లా చేస్తాం బికాజ్ సమ్టైమ్స్ కొంత తప్పు చేస్తాను, కొన్ని జాగ్రత్త చేయాల్సి వస్తుంది. Okay, students, this is how we have discussed questions chapter 6 to chapter this one. Okay, students. Okay, students. I'm doing